start. So, welcome on Breakout session, case number 2, polymer flooding at a giant mature field in western Kazakhstan. And the main question is, what are challenges ahead? My name is Timur Ispanbetov. I'm an independent expert. Previously worked at the KMG Engineering in Atro and Naktal, and I'm familiar with this case. And I prepared this case in collaboration with KMG Engineering and with my colleague Darya Musharova and others. So let me start. Briefly about the oil field. So this is a giant oil field in the western part of Kazakhstan. This is Uzain field, and what are key facts you should know? So reservoirs are Jurassic sandstones, so classic sandstones in deltaic and fluvial environments, and very highly layered structure, so permeability contrast more than 4. This is one of the main reasons we wanted to implement polymer flooding at this oil field. And as I said, it's giant field and large-scale developments of more than 1,000 injectors and more than 2,000 producers. So the development started in 1965, and over the 60 years, water cut increased dramatically up to 90%. And peak of oil production was just after 10 years after the development. So in 1975, it was around 110 billion barrels of oil, and current rate is about 37 million barrels of oil. And so the lower graph, you can see one more reason to start EOR on this field. So early water breakthrough is observed. As you can see, high water cut around 90% and oil recovery less than 80%. Here is a spider graph illustrating fields characteristics such as temperature. So temperature is a little bit higher than 60 degrees. Oil viscosity, it's a low viscous oil, less than 5 centipoise. Relatively low permeability, 100, so it varies from 20, even 20 to 200 millidarcies. Also, brine salinity is 60,000 ppm, and depths around 1,200 meters. So as you can see here, we put maximum and minimum frames, and it allocates inside the diapason of polymer flooding implementation. And comparing with two most popular polymer and SPE flooding projects with Dachin and Mangala, you can see that the characteristics are so very similar. Some characteristics, geological characteristics, are similar, and we can consider that polymer flooding is applicable for this field. But the first constraint we faced with is pilot area selection, and as I said, over 4,000 producers and 1,000 injectors, but there is a significant problem to choose one proper pilot area to start, because we need to choose the best one to show that polymer flooding, as Flavian said before, it's proven technology. Polymer flooding is no longer uncertain technology, it's proven technology, and that's why we believe that it will work, but we need to choose proper pilot areas. So here you can see top 22 pilot areas we selected, and only one, so this one, number 9, is the best of the best. Oh, sorry. So three criteria well pattern. So well pattern is good for this field, but I have to mention that well pattern is one of the main constraints here at Musen field. Faces, some mainly enhanced channel belt, and availability of low salinity water from Almaty horizon. So here,
When you say low salinity water, how low?
about 10,000 ppm.
10,000, and then how about the divalence?
I will show at the next slide.
Okay, sorry.
So from 20 plus sites on the best available pilot, so try to prioritize these sites, and it's important to mention that different water sources were used in this field. For example, in this area, in purple circle, seawater is injected. At the center of field, produced wastewater is injected, and in the red circle, we can see the area where alcinamide low salinity water is injected, but only from 2024. And previously, seawater was injected. So here is an answer for your question. We have three main sources of water. So low salinity water from Cretaceous, from Alcinamanian horizon, with calcium and magnesium around 200 and 100 ppm, and so total salinity, as I said, 10,000. And we also have Caspian seawater. Here is sulfate, more than 3,000. And the most important thing, why we did not consider Caspian seawater as a main water source, is that dissolved oxygen, you see, almost 5 ppm. This is the main criteria why we choose, why we chose low salinity water from Alcinamanian horizon. And produced water very high content of TSS and residual oil in water, and also total salinity is high. Calcium concentration is very high, more than 3,000 ppm. That's why produced water also has not been considered to be as the main water source for polymer flooding. Here we have a map of polymer flooding pilot area. So we have two injectors here. So the third injector is not considered. And 17 producers. And it's only 0.2 and 0.5% of injection and production well stock. And the key moments, or let's say key constraints here are, as I said, water source. Low salinity water is available on this pilot area. Low permeability, so low permeability is one of the main constraints almost at this field, but we choose the area in channel zones. And the third one, well pattern. So water flooding system is spotty without structured well pattern, but we try to choose the best one. And according to simulations, expected polymer utility factor is 50 tons per 1 ton of polymer injected. So now we have several questions to answer. So turning insights into impact. So the first one, the absence of clearly defined well pattern. And my question is, should infill drilling be considered as in Dutchin case, or maybe you will have another solutions?
So I'm just curious, go back to the last slide. Did you do any tracer work to see how the
Yes,
the
actually.
links are with the injector to all those producers?
Yeah, actually.
What's the connectivity?
Very low connectivity actually between the injectors, and producers even in the channel zone. This was surprise, but I don't know how to interpret the tracer results, but the fact is very low connectivity between these injectors and producers. And we believe that channel zones, maybe we don't understand according to tracer test, it should be that connectivity should be good enough.
Yeah.
Yeah, it's our assumption. Because if we choose on this area, so it will be not applicable and not feasible.
Did the geologists have any comments why that
This-
things are not connected better, or?
Generally, this area, enhanced channel belt, has very similar geology.
Mm-hmm.
And that's why we had the assumption that Polymer will get to this producers.
Right.
Yeah. So, but again, it's only our assumption.
Right.
Yeah. So the second question is technical condition. So well stock, as I said, development since 1965. Over 60 years, and should new injection wells be built specifically for polymer flooding? This is not the main question, but still I think we can discuss on this point. And third one, key performance indicators, and this question is provided by our contractors, the company who is responsible for injecting, who is responsible for polymer and facilities. So they want to know how do project-specific features impact economic evaluations, and maybe you will provide another cases from your experience. And any other suggestions for improving polymer flooding and for potential full field scaling or potential improving polymer technology at this oil field. So at the end of this breakout session, we want to generalize all the brainstormed information and the expected results are expert studies. You as experts, we expect from you to share experience-based advisory solutions. So,
Please
yes.
turn on the light.
Please ask your questions. Yes.
Yes, I came late, and I don't know if you have shared any laboratory studies on
No.
polymer evaluation.
No, I didn't share. I didn't include the information about lab studies.
And you have done some?
Yes. Usually we use, in this oil field, we use standard ethanol polymer.
Which one? The high molecular weight?
Yes. High molecular weight.
3630?
Yes.
And so what's the permeability? You said it was low.
100 millidarcy.
100, okay.
Yeah, the average permeability. It varies from 20 to 200 millidarcies. And maybe a little bit higher at channel, at enhanced channel zones.
Person you were targeting one zone, silver layer together for pellet foot.
Yeah, several zones actually, that I showed. So you see the two zones. So here, three main zones, A, B, C. Yes, but C is not in our focus because C is low permeable. Oh, no, sorry, not low permeable, but it's I think it's with very high recovery and no perforation yet because water comes from this section. So only A and B sectors are considered.
Yeah, so you mentioned that the channel belt mainly for the B, right?
Yeah, mainly for B, yes. And the main reserves are at the B sector.
And Timur, one question. So for the pilots, you reached 50 tons of oil per ton of injected polymer, which is very good economic.
Yeah.
For the full field model, are you reaching equivalent ratio? Or?
You know, we did not calculate
Okay.
actually, but now from the project started in March 2025,
Mhm.
and for half a year now there's no very good response. That's why we can't provide this value for full field scale.
Okay.
It's uncertain,
Yeah, that's
but it's like a goal target. It's goal number
Mm.
of 50. So
Right.
economically valuable, feasible.
I think you said you've been injecting for 7 months, and the simulation says you should be seeing some response, but you're not,
Yeah,
Right.
right.
right? And I think you also mentioned that your oxygen level was higher than, it was 0.08, right, coming out of the aquifer. But your injection, you're picking up a bit of oxygen?
Yes, there is a problem with oxygen actually, and it's around 2 ppm, which is I think 100 times more than expected.
Yeah.
There is a problem, yes.
So that's coming in from as you're mixing the bulk?
Yes,
Right.
yes. It comes from water source.
Well,
Due
the
to
water
some
is, but coming out is 0.08, right? What's coming
Yes.
out of the aquifer?
Yes, it comes to facility
Right.
0.8, and I don't know, somehow there are some facility features after facilities, after water treatment facilities,
Right.
water comes with 2 ppm.
Right. So maybe one recommendation would be to investigate how the oxygen is coming in, or what can be done to mitigate that. Whether further nitrogen blanketing. I was talking with Randy Seawright, and he said the same thing happened in Mongolia. They had quote unquote leaks, and then they put in some more nitrogen blanketing, principally in the funnel where the polymer powder is coming down and getting mixed in with the water. There was some air ingress, right? And then, I mean, I'm not a facilities designer, I don't know exactly, but I can imagine that when you're bringing that polymer powder down, turbulent mixing, which is what you want to get about a surface area of the polymer, and there can be some leaks or something. Maybe that's something to.
To come back to your point, Jeff, if I may, in Mangala, Kern is using eductor, which is
Okay.
quite, I would say, low quality equipment for
Right.
polymer solution preparation. With the PSU, there is a nitrogen overpressure blanketing,
Okay.
preventing from any oxygen ingress.
Okay.
So this should not happen.
So then we need to look at how is oxygen getting in? If it's not there, it's gotta be somewhere
I agree.
else.
I agree.
Because you're starting with 0.08, you're ending up with 2.
There is a
So I
problem
think
somewhere.
some sort of task force or whatever to kind of investigate.
Yeah.
Because, yeah, I'd say the other recommendation I would have is take some samples of the polymer as it's going down the well, put in an oven at 60 degrees, and see if the viscosity is holding or not,
Yeah,
right?
Right.
Just take some well samples and
From the wellhead.
see if that extra oxygen is hurting you or not. Maybe it's not. Maybe people always say the reservoir is a reducing environment. It can tolerate some oxygen because oxygen absorbs on the rock. But you don't really know.
To take samples from maturation tank, and to measure oxygen concentration
Or
in
if
the flow.
you could even take it right at the wellhead. I don't know if you could do that or not. You know, before it goes down, just take
Yeah,
one of
we
those
can
little
do.
bombs, take some. It's tricky to take samples without getting oxygen from the air. We did it in Oman a few times. It's a little tricky, but
Yeah.
it's worth thinking about, yeah?
Yes.
But I think, I think you've identified very well two issues. One is that oxygen, is it a problem? And the other was just the conformance, what wells are connected with what,
Mhm.
right? I mean, if you say the tracers didn't show up, I've been involved with a couple of projects where exactly that's happened. There was an early one called Coalinga in California, 1978. It was unbelievable. This well came over, it was like completely different than what the geologist said
Mm.
should happen, right?
Yeah.
I'd like to ask some questions about this polymer flooding. So according to your expectation, target expectation, what polymer concentration are you going to use and what amount of injection PV for volume of polymer solution will be used according to
This project.
expectation? Yeah.
Yeah. So the polymer concentration is 1,000 ppm.
1,000 ppm?
1,000 ppm with the target viscosity of 11 to 15 centipoise. The average is about 11, 12, maybe centipoise.
So at that case, what's the viscosity of the polymer solution? Because I see your the salinity with high calcium and magnesium maybe affect the viscosity a lot.
Right. Yeah.
Yeah.
And actually, they increased the concentration up to 1,300 a little bit, but
So that 11 to 15, is that at 60 degrees C? Or that's
Yes,
at room
yes,
temperature? 60 degrees C?
Yes.
Yeah, okay.
So I think
oh,
compared.
sorry, no, at the surface condition.
That's the
Yeah,
surface.
at the surface condition.
Right,
Yeah.
so at 60, it's gonna be
Yeah.
7.
Yeah.
I think according to the Dutch oil field, the experience usually, if we use the polymer solution, 1,000 ppm, usually we injected the polymer about 60% polymer solution. At that time, we can get 1 ton polymer can get 150 crude oil. So I just saw you want to get only 50 ton crude oil, almost 1/3 of Dutch crude oil production, oil recovery.
Yeah. Right.
Yeah, so I think maybe the viscosity is much more lower than the Dutch oil field polymer flooding, right?
So viscosity of polymer solution, you mean?
Yes.
So lab tests and field tests show that it's around 11, 12 centipoise
Or
at
11
the
to
surface. But you mean it's not enough for this case?
12. Yes.
Yeah.
What's the oil viscosity again?
Well, 4.5 centipoise.
Yeah.
Well, it should be enough.
Usually Dutching is about around the 40 centipoise. 40.
Yeah, but the difference is in Daqing, the type 1 reservoirs, permeability is more than 1,000. So here only 200. So even lower than our type 2.
Yeah.
So that's the problem. Why I think they use a relatively low concentration.
And one more constraint is economics.
Yeah,
That's
it's
right.
not be injected.
Uh,
So I think we move to your main question, whether we can field drilling, whether we need a standard pattern, right? That's one we want to solve.
yeah.
Okay. Add to the per ton of polymer power incremental recovery. I agree that Professor Kang still a little conservative. Even in Daqing 200 oil incremental for per ton of polymer, but at least here we reached from 50 to 100 that's possible, just the gas feeding.
So average number for Kazakhstani projects, previously for over 10 years we have polymer flooding projects, Nurali, Kalamkas. So the average number is about 40 to 90, but 90 is the best case.
Okay.
Average is 40, 45
Yeah.
incremental oil per 1 ton of polymer.
Yeah, I think also the big difference between the Kazakhstan, the connection between the wells, I think is not maybe much more worse than Dutch oil, because in Dutch oil the oil connection is very well, but here you just said it's not good. right?
Heterogeneous, non-related contrast.
How do you measure the polymer concentration, the produced one, that you're saying?
Yeah. So first of all, yes, we made simulations at Eclipse. So it showed that we have to inject 19 centipoise solution, polymer solution. So when the incremental oil production goes plateau, and that was the first thing. And the second thing was incremental oil from lab tests that showed that even lower polymer solution viscosity can be applied. That's why we decreased the target solution viscosity from 19 to 50, and then due to some feasibility constraints, so the range was even lower, a little bit lower, from 11 to 15 centipoise. But now it's about 12 centipoise.
So this is depending on the viscosity itself. No? How deep is this reservoir?
1,200 meters to 1,200 meters deep.
And the injection pressure, was it high?
Yes, initially it was high, about 100 and from 100 to 120 bars with water injection and with polymer injection as well. And no significant increase in wellhead pressure. Yep.
So this means that polymer is not traveling.
Or maybe there are fractures.
Fracture.
Yeah, maybe. That's why tracers doesn't work well. Maybe.
Yeah, but they should come out somewhere, right?
Yeah.
I mean, it's kind of concerning that you don't see them coming out anywhere. I mean, I don't know if it would be wise to run a tracer survey again to see if, it's a little puzzling.
What's the well
Unless it's
distance?
going into a different zone, I don't know, yeah.
What's the well distance between injectors and producers?
So the average is about 500 meters. So this one is closer, but the average well spacing is about 500. So this well spacing is much bigger, around
Right.
1 kilometer. So it depends. So as I said, there is no
Clear pattern.
well pattern. So this is one of the main problems.
Right.
Okay, so for me, I think that now that is a pilot, we need to try to get relatively reliable results. So
Right.
in-field drilling using 5-spot pattern with the well distance considering the relatively lower permeability, using the well distance between the injector and producer less than 250 meters.
As Dutch in case, right?
Yeah, because we can, even touching is better than your reservoir properties. So still using that, so maybe we reduce to less than 200 meters and give good one pattern in a 5-spot maybe. Also,
The 5-spot with 4 injectors and a central producer?
Yeah, one injector in the center.
Then inverted 5 spots, so
Oh,
one
yeah.
injector, 4 producers.
Yeah, four injectors.
Oh,
in
4
the-
injectors, 1
One-
producer.
one,
So
yeah.
then you really have it confined.
Yeah,
Yeah, I think that's a
That's
good-
because the
I think
pattern.
that's a good recommendation.
That's a pattern.
Before you
right?
ever think about going full feed.
Yeah,
You know, you gotta know that
yeah.
this is propagating and this is working and.
Yeah, give the confidence, get
Right.
confident results. No matter it's good or bad, right?
Right.
At least, so, use a new infield drilling policy. And during the process, we need to consider fraction. If, let's say, after the infield drilling, we feel the reservoir is even lower than our expected conductor fraction for the injector. You mentioned permeability contrast is 4.5, right? That's a different layer, right?
Yeah.
Okay, so maybe in the process also or conduct a profile modification. If let's say the permeability is great difference for the A and B, so that's the basic to ensure the injection.
You mean to use conformance control treatments?
So, yeah, before the polymer plant conducted the profile modification, even that. Also, if let's say that the very low in the A conduct fraction.
Gents, can I give a comment on this?
Of course.
Actually, if we look at the history of cumulative oil producer in this zone, the size of the map doesn't show it, but in this particular zone, we see that there are much bigger bubbles there. So, and all the wells surrounding this zone, they have much smaller bubbles. So that it also supports that there is a channel belt existing, and yes, this was our a big assumption that there is something a big, and the connectivity should exist there.
Right.
So yeah, if we look at the different scale, like a bigger scale, we can see that.
Yeah, right.
So one thing I want to emphasize again, I think before you drill wells and do a constrained pilot, I think we need to really investigate this oxygen question.
Yeah.
Because it would be not wise to spend all this money and drill all these wells if you're not gonna get a good result because you haven't solved the thermal stability question.
Yeah,
I
additional
think that's the
solutions.
first thing to solve. Figure out, is your polymer stable? Take some wellhead samples, put it in the oven, and if it isn't, start looking, where's this oxygen leaking in?
Yeah.
And I'd say that's the number one thing, and then you sure you've got viscosity remaining in the reservoir, then I totally agree, a constrained pilot.
Yeah.
And then you can really determine what's your efficiency. Are you really getting 50 tons per 1 ton of dry polymer? And then you can start calculating to the bigger reservoir.
Yeah, right.
But now there's just lots of uncertainties.
I forget to mention that nitrogen is used here. Nitrogen blanket is
Right.
used as a standard SNF equipment design.
Mhm.
But 2 ppm is inside, so it comes to facility to injection facility with 2 ppm.
Yeah.
Yeah.
So I don't know, is that acceptable? Randy Seawright says, it's not, we need to get lower. But where's the leak, where are the leaks? I don't know.
He says 10 ppb, which is
Yeah, well, pretty darn low. Other people say a bit higher, right, but,
yeah.
Almost zero.
Can I add something?
sure, of course.
Timur, you emphasized several times the choice for this pilot area, and you really emphasized the fact that there is a water availability here, right?
Yeah,
But I was just thinking maybe you can, close your eyes on this particular feature as water availability,
Yeah.
and try to go see surroundings. Maybe choose another pilot area, even though we inject different type of water there. For now, we gotta answer the question if it works or not, if we have connectivity between wells or not, and some other questions. So maybe choose another pilot area. That's my question to you.
Yeah. As I showed, so even if we consider that there is the water availability of all the sources anywhere, this pilot area is still the best one. So that's why low salinity water up to Nemanja was implemented here this zone 1 year before, because the operator prepared this zone for low salinity injection, especially for this pilot area. So operating company made the best solutions for water source in this area.
So it's not an option. Okay.
Well, the water on paper, the statistics, the specs look really good. 10,000 ppm, pretty low count.
Yeah.
And well oxygen coming out of the aquifer, right?
With calcium and
I
magnesium.
mean, it looks very good.
Very good. Yeah. Less than
I mean,
0.1.
yeah, it's,
Timur, maybe you yourself, maybe you can see any other problems. Maybe you didn't mention anything, something else for us. Maybe you can. I mean, what is your personal opinion on this case?
My personal opinion is included in this blue questions. So maybe infill drillenness batching case, and maybe drilling new injectors. So these are my assumptions. But if for example experts have another opinion, we would consider and we'll discuss. And I think these constraints are enough for very short breakout session, and I think timing is that we have to discuss only 1 hour, right?
Yes.
Yes, and I think these two or three questions are enough for now.
Does anyone have anything else to say?
What about well testing? Is this something that you have done with well testing to see the connectivity between these wells?
Yes, so pressure transient tests were provided before the Polymer flooding, and
Pulse testing? Pulse testing?
not pulse testing.
About testing this.
Здесь, да, КПД.
Потом спрашиваю.
Да, no pulse testing, but well testing is КПД, как на английском?
Pressure support.
Pressure transient, yes. Yeah. And so
All of this.
in some areas there are like fracture-like features, in some areas, but as we discussed with Antoine, he says that generally there should be a matrix structure at such fields with such behavior of water cut, so no sharp breakthroughs. So I think that there is something average between matrix and fracture-like features. It's just a mixture of geology.
I have a question adding to that question about the well test. Did you try to quantify the average drainage area of the wells? Can you calculate from well tests, from build-up tests, let's say? Maybe it will be a good information to the question if we need to drill new infill wells.
Very good question, but I think I have to ask my colleagues Yes, but I don't know exactly about the calculations of particular wells of this area.
Also, second question. Thank you for the presentation, Timur. In your opinion, or maybe for this pilot, what would like to implement, but you didn't have enough resources or funding, and unfortunately you did not do it at this stage?
Well
to gather
pattern.
more information?
Well pattern first.
Thank you.
I would start with well pattern and then with polymer solution viscosity.
Otherwise, do you think you have enough resources, like enough support from laboratory, any other surveillance jobs? Maybe it's something you would like to do, but you cannot do at this stage to do some additional surveillance?
You know, lab tests are made 3 times in 2022. Yes, for 3 years there were lab tests, and we tested more than 10 polymers. I think around 15 polymers, or maybe more. That's why I think we have enough information about polymers and the lab tests, both filtration tests, so core flooding, and static tests. So I think for now it's enough, I think.
I have also one recommendation.
Yeah.
My understanding, this is case 12 injector, case 12.
Yes, yes, yes.
Casing.
Yes, yes, with casing.
What about the cement pond load? Maybe something with the cement itself, or?
These 2 injectors, there are no significant problems with cement bond. But generally, I mentioned then, if we will go for full field, there may be some constraints due to old well stock. But for this case, for this pilot area with 2 injectors, appropriate cement bond.
So maybe there is a chance for the injected polymer to go to another formation within this well.
Yeah, I understand your point, yeah. So during the traces, we did not see any significant crossovers and leaks, yes, from another horizons, from another objects, yes.
So how much we are familiar with the geometry of fractures? I mean the direction of fractures and horizontal and vertical lengths of fractures. Are we familiar with these parameters? Because the answer of all these questions are related to exactly the geometry of fractures. If we have deep understanding on the geometry of fractures, we will be able to answer to a lot of questions that we have right now.
You're right, yes. Maybe this is a key point here, but to be honest, we don't know much about fractures geometry, because we even don't know whether they are fractures or maybe some, as I said, mixture of fractures and matrix-based geology.
So what does regional study tells us?
Regional studies?
Regional study of this area, I mean stresses, geomechanical surveys, what do they tell us related to these fractures?
So it all depends on the history of injection, and for example, this area, which is not enhanced channel area but floodplain, these green areas, for example, floodplains. Maybe there should be some big fractures because of when we make hydraulic fractures. So we see that the effect and the response from producers. But I can't answer clearly for your question what are the differences between these phases and what are the fractures in this area, because we don't have enough information.
And is there seismic data on this field?
Yes, sure.
And we don't see anything in seismic data as well? No.
Тут вообще геомеханические исследования были по направлению стрессов?
По ГРП
Ну, в
вообще,
целом, да.
вообще были, просто у меня сейчас нет ответа на руках. Значит,
Вопрос
Ну,
был
по-
про это, кажется.
да,
Ну, в
вообще
целом,
ГРП здесь-
регионально.
Да. Вообще ГРП здесь проводится именно на этом месторождении, даже на этих
Горизонтах?
Да, на этом горизонте, на этом участке даже некоторые скважины были. То есть, вот в этой зоне точно были.
Тогда
Я понял, да, вопрос.
можно, в принципе, изучить это.
Да.
So I've been asking if there was any geomechanical studies within these fields to see the direction of the stresses and to understand where
Yes,
these studies
right.
was going
Right.
as,
A very good point.
what you asked from your question. So they're doing the hydraulic fracture even in this horizon, but they didn't get much study which direction it goes.
But maybe if seismic is not good for understanding this one, maybe as the colleague mentioned, we have to do some more focused, well-tested surveillance just for getting an idea for the direction. Why it is important? Because, for example, maybe the length of fracture even cover both of these upper and lower horizon, and you inject it from the lower horizon and it goes through the fracture and you don't know where.
Yeah, right, very good point. Yeah.
That's why I think there should be a study before everything. There should be a study.
Right.
Okay, thank you very much, Timur. So, dear guests, dear participants in this breakout session, we are going to now put our efforts to make this protocol for minutes meeting, and I will try to briefly describe. I will try to briefly, concisely describe what we have discussed here. Whichever questions you asked and Timur answered, I try to put it in this paper, and then I will ask you all to take a look at this paper and at this protocol, and if you agree with the recommendations, with the conclusions, please sign it. We will print it out. It will be here on the table, and I will ask you to put your signature if you only agree with these recommendations.
Also, before we will start with meetings, Jeff as SME has his own vision about this case. And
yeah, I mean, I think all the comments are really good. I mean, I think I summarized what my feeling is before. My view is to, address that oxygen issue. Get some solutions from the wellhead to test in an oven. See what your stability is before you spend large amounts of money on anything else. And if the polymer solutions are degrading in the oven, get a task force together with some of your suppliers and see where the leaks are. And then if that's, solved, then I'd think about it like doing a confined pilot, drill 4 wells with a central producer and really nail down the performance of the polymer before you ever go to a larger field. But once you really nail that down, what is the efficiency of that polymer at that viscosity displacing the oil? Are you getting 50 tons per ton? Yeah, I think that's my view, those 2 points really. And all the others' comments are very good about, understanding fractures.
So now it's time for you. You can come here to this table and maybe make your corrections with me here. I will be glad if you help me out here. And dear Dr. Jeff, please take a look at the screen. And can you see it?
Yeah, I can.
Okay.
I'm just sitting in the front here.
I can actually enlarge it.
Yeah, I don't know if Fabi, do you have any other comments? You're a kind of equipment expert, and do you agree with that, or do you think it's something else?
Well, I agree that we are clearly missing sampling points at the wellhead, because I'm more or less confident within the preparation facilities, but what is happening upstream or downstream, we don't have control of it.
Right.
So I fully agree with this point. And then I agree that we are missing possibly a confined area within the reservoir to make sure that the producers are coming from the injectors. I mean, the flow is coming from the swept area. And I think 2 injectors per 17 producers, the ratio is too high. So an inverted 5 spots could be a solution.
Right. It might be a little bit expensive, but then you really know. You know, I like the suggestion, 250 meters, before you spend, billions of dollars on a full field. I mean, you really need to nail down a couple of key points.
And coming back to the pilot, so you mentioned, Timur, that the oil response was a bit longer than expected. Did you start to see something, or not at all?
No significant response.
No significant.
Yeah.
And with the simulation, it was expected after how many months?
How many what?
So how many months of injection?
Second or third month.
Okay, we were reaching 7. So, one possible reason is that we are not sweeping the proper area.
Okay, that's a good summary.
Thank you. If you guys want to have a small break here, we need to finish in 35 minutes. So we've got about half of an hour to finish this protocol. If you want to have a quick discussion with Timur on some other points, please welcome to this table. Now it's kind of free time. You don't have to sit here and look at us. You can come here and talk with us, or propose your ideas, or ask your questions. We'll be happy. But for now, it's absolutely free time for y'all.
Okay.
So thank you very much.
Yeah.